How's it going, Sioux High Earth Science students? Yep, this is Mr. McLeod again. Welcome to the Part 3 podcast and our continuing discussion of the Earth, Sun, and Moon system. In this podcast, we'll continue our discussion of the solstices and equinoxes, whatever, and get started with the phases of the moon. So get your notes out and something to write with, and let's roll. Okay, let's trudge on towards winter. Oh man, you mean summer and fall are gone already? Sheesh. Now, winter supposedly begins on December 22nd. So write that date in your notes and call it the winter solstice. So we're over here on the left-hand side at the date December 22nd, and we're calling that the winter solstice. So get that in your notes, the winter solstice. Now, let's try to make some sense of this. December 22nd is the shortest day of the year and the longest night of the year. So get that in your notes. Shortest day of the year and longest night of the year. So what that means is we have 8 hours of daylight and 16 hours of darkness. So get that down as well. Also write that the sun is as far south as it will get. Therefore, we get the least amount of direct rays. And boy, don't we feel the temperature change because of it. Brrr. Get that in your notes. Not the brrr, I don't know how you spell that, but get that other thing in your notes. It's worth mentioning that snow and ice cover contribute to our cold temperatures by reflecting the sun's rays that would normally heat up the ground. That's why it's taking so long this year for us to warm up. The Great Lakes have frozen, and we've had so much snow cover that even though right now we've got an increase in the amount of direct rays, they're being reflected by the ice and snow. And that's the main reason we stayed so cold this winter. So write that in your notes. Now let's look at the tilt of the Earth again. Write in your notes that on December 22nd, the southern hemisphere is pointed towards the sun and the northern hemisphere is pointed away from it. So here we are now in winter. So we're over here looking at this diagram right here. And now we're looking at its relationship to the sun. So here we are in North America, and we're now pointed away from the sun. Whereas down here in the southern hemisphere, that's now pointed towards the sun. Now that's contrasted over here in the summer when we were pointed toward the sun in North America, and the southern hemisphere was pointed away from the sun. So we're over here in winter and the northern hemisphere pointed away. Now remember, it's not that we switch back and forth axis-wise. It's just by tidal lock, by the time the Earth gets over here, it's pointed away from the sun. Okay, so let's review. We've started here in the spring. We've made our rotation here into summer. Way more direct rays because now the Earth's pointing toward the sun. Now we're making our way towards fall, where we've got less direct rays in a perpendicular axis to the sun. We've now made our way to winter, where now we're pointed completely away from the sun and our amount of direct rays is like almost nil. So now what we want to do is we want to make the home stretch like we're doing now towards March 21st. So let's finish with spring. So write down that spring begins on March 21st and that's called the vernal equinox. Here's the word right here, vernal equinox. Vernal means spring, so it's also called the spring equinox. So get that in your notes. Now it should be second nature. Again, remember that equinox sounds like the word equal. So on March 21st, there are equal amounts of day and night, 12 hours of each. Make sure you write that in your notes. Now, from an Earth axis standpoint, the Earth's now again axis at a right angle to the sun. All right, right angle to the sun, just like at the autumnal equinox up here, right angle, meaning the Earth is not pointed towards or away from the sun, but at right angles to it. Now, because the sun is now making its way back north, its rays are getting progressively more direct, just like is happening right now. So each day we move on in the spring, we're now into the beginning to middle part of April, the sun's rays get more direct. Now, if you don't have that in your notes or don't understand it, get that in your notes. And by getting progressively more direct, the possibility for warming the surface of the Earth is getting greater as well. And remember, if we can warm the surface of the Earth is what's responsible for warming the atmosphere. So therefore, our daily temperatures would tend to increase, which they're just now starting to do. So make sure you get that in your notes as well. Okay, just for review purposes, let's take a look at this diagram again and see how it moves. So you can see the orbit path of the Earth around the sun. And you can see now by the tilt of the Earth, that's what the key to the whole thing is, the tilt, where the seasons are. So again, let's look at winter right here, where we're pointed away from the sun. And we're making our way towards spring now, the vernal equinox. And from vernal now, we're making our way towards summer. You can see northern hemisphere pointed towards the sun. Here's autumn again. And now we're back to the beginning. So the key is to look at the lit area of the globe in this diagram, and that will tell you what season it is. And it's best to start with summer or winter. Here's summer with the northern hemisphere pointed towards. So we go from summer to fall, and then from fall to winter where it's pointed away from the sun. So just a nice visual review of the seasons and the equinoxes and solstices. All right, now it's time to move on. Okay, now on to the phases of the moon. It's still amazing to me that we see the moon nearly every day or night in our sky, yet almost nobody understands why we see what we see of the moon. And even more interesting is when we see these phases, meaning day or night. The primary key to understanding moon phases is to think about where the sun is in the sky. Remember, it's the sun that's lighting up or illuminating and creating the day side of the moon. That's why we can see it. Moon phases depend on the sun. They depend on where the moon is with respect to the sun in space. Write that down. Now, another key to understanding moon phases is to remember that, like the sun and all the planets and stars, the moon rises in the east and sets in the west each and every day. Write that down. Now, we said that the moon rises in the east and sets in the west every day. It has to. The rising and setting of all celestial objects, is due to Earth's continuous spin beneath the sky. Write that down as well. All right. Also remember that the moon takes about a month to orbit the Earth. And although the moon rises in the east and sets in the west each day due to the Earth's spin, it's also moving on the sky's dome each day due to its own motion in orbit around the Earth. Write that in your notes. Let me repeat that. The moon's also moving in the sky on the sky's dome each day due to its own motion around the Earth. Now, the moon's orbital motion can be detected in front of the stars from one night to the next. It's as though the moon is moving on the inside of a circle of 360 degrees. What that means then is the moon moves about 12 degrees each day. Write that down. Now, the last thing to remember is that the moon's orbital motion is toward the east. Each day, as the moon moves another 12 degrees toward the east on the sky's dome, the Earth has to rotate a little longer to bring you around to where the moon is in space. Man, you definitely got to write that down. So let me repeat that again. Man, that thing goes off a lot. Let me repeat that. The moon's orbital motion is toward the east. So each day as the moon moves another 12 degrees toward the east on the sky's dome, the Earth has to rotate a little bit longer to bring you around to where the moon is in space. So make sure you write that down. Now, what that means is that the moon rises on average about 50 minutes later each day. Definitely write that down. The moon rises on average about 50 minutes later each day. Now, the later and later rising time of the moon causes our world to appear in a different part of the sky at each nightfall for about 2 weeks. So get that in your notes. What that means is that in a couple of weeks after the full moon, and we'll talk about the moon phases, you'll find the moon rising later and later at night. That's why we don't see the moon on the exact same day every day of the month, because it rises 50 minutes later. Really important concept to understand. So let's take some notes. It's really important to understand some terminology and positioning of the sun, earth, and moon before we actually take a look at its phases. In the picture on this slide, you see our moon going through all its phases. We are about to learn what all those mean. So, write the word waxing in your notes. You see it right up here. So write the word waxing in your notes. That's important. Waxing means that every day or night we see a little bit more of the moon. So write that down. Waxing phases, we see a little bit more of the moon. Now in a bit we'll see why that happens, but for now understand that the portion of the moon visible is increasing like they have right here. Increasing. So we're going to go from not seeing the moon at all to seeing a little bit more of it. These are the waxing phases. Also write in your notes that this is when the moon is between the new and full phases. Now we're going to understand more about that here in a second, but between the new and full. So more of the moon is showing itself, and this is between the new and the full moon. Okay, now write the word waning in your notes. You see right here the word waning. The word waning, write that in your notes. Now, during the waning phases, the amount of moon we see is decreasing. In the waxing, we saw that they're increasing. This is the portion of the moon visible is decreasing, which means we see a little less of it every day. So write that in your notes. Also write that the waning phases are when the moon is between the full and new moons. Between the full and new moons. So get that down in your notes. Okay, now for the positioning of the sun, moon, and earth during the moon phases. First of all, notice where the sun is in this diagram. So right over here on the left, you see the sun. Understanding the moon phases requires that you know where the moon is in relation to the sun and the earth. Write that in your notes. So the moon phases requires that you know where the moon is in relation to the sun and the earth. Make sure you get that down. It's also important that you know that the moon wobbles in its orbit around the earth. Write that down and then we'll explain it. That the moon wobbles in its orbit around the earth. We're going to use this diagram in this slide to help explain it. Now let's explain wobbling. Now, wobbling means that the moon moves up and down in its orbit in relation to the sun due to the slight tilt angle of its orbit path around the earth. So write that down. Remember, you can pause this and go back. Wobbling means that the moon moves up and down in its orbit in relation to the sun due to the slight angle of the Earth's orbit path, or the moon's orbit path around the Earth. Write that down. Okay, take a look at the diagram in the slide above and reproduce it in your notes as best you can right now, and make sure you label it correctly. So reproduce this diagram as best you can in your notes and label it correctly. All right, here we see the flat plane of the Earth's orbit around the sun. This dotted line represents the Earth's orbit around the sun. So if we can imagine that as a flat plane, all right, in other words, it kind of looks like the horizon, so it's kind of flat. What I want you to notice is that the moon's orbit path is at an angle to that flat path the Earth takes. So here we see now the orbit path of the moon. And we can see that it's not in the same plane as the Earth's. So here's that orbit path. In fact, it's at a 5-degree angle. So write that in your notes. It's at a 5-degree angle. So this angle right here is 5 degrees. So it's tilted at about a 5-degree angle to the Earth's flat plane orbit path. So make sure you write that 5-degree angle in your notes. It's also right over here. It's a little mirror image of each other. There's another 5-degree angle right here. So the moon's orbit path is tilted about 5 degrees to the Earth's flat orbit plane. Now, because of that angled orbit path, the moon moves up or ascends in its orbit path. And you'll see here that they have this thing called an ascending node. So what happens now is the moon starts to get progressively further above that flat plane as it goes this way, and eventually gets to the top of it here at its orbit. Then it moves back down again in its orbit path, called the descending node. So here's the descending node right here. So eventually it gets around this way and begins to descend. In this orbit path. Write that down in your notes. And you're going to need to refer to this diagram and these concepts here very soon when we start talking about eclipses. Now, what results is that the moon wobbles or ascends, meaning it ascends above the straight line between the Earth and the moon. In the sun, rather. So if there's a straight line between the Earth, sun, and moon, that moon now ascends to up here and descends, we could put a little circle right here, down to here. So that we call that wobbling. This becomes very important to our understanding of lunar eclipses and why they occur, and solar eclipses and why they occur. So make sure you get this diagram and the explanation in your notes. Okay, now this concludes our intro to the moon phases. So go and grab those questions on Moodle, answer them, submit them, and then we'll get more specifically into the real moon phases, moon phases in the next podcast. So I'll talk to you soon.